So my plan today was to do a video about Zig 014, introducing one of my favorite features from Go into Zig. Um, let's just pull up the screen. Okay, so as you can see here, I'm running Zig build test fuzz. The spoiler here is fuzzing is one of my favorite features from Go, and I was hoping to do it in Zig and do a nice little tutorial on that and how it all fits together. But I ran into this very interesting LLVM error. So SANCON Gen 0 has an invalid section specifier. SANCON CNTRS, which I assume is counters. MacO section specifier requires a segment and section separated by a comma. I don't have a clue what that means. So I Googled it. And what I found was that it led me to this. So if you try using fuzz on macOS right now, it results in this. So this is reproducible with Zig init. That's exactly what this project is. In fact, we'll get to the source code in just a second. The short and sweet is I can't run the fuzzing on my Mac. So I was going to do a video on that and show you how to fuzz and how to do really cool things. If you want to learn fuzzing and kind of see my approach to fuzzing, I've done a video on it in Go. I'm going to put that right up here. So there'll be a link for that. And then I'll also make sure that at the end of this video, that's the one that's suggested for you. So if you want to learn more about fuzzing and how it works and what it does and when you would use it, go check out that Go video. If you can write Zig, I guarantee you can write Go. Go is simple, straightforward, and yeah. So I think you can get a lot of value out of that if you know Zig and don't know what fuzzing is, and whether you do or don't know Go. Anyways, I want to use this opportunity to talk a little bit about a couple other things instead. So just a reminder that Zig supports a ton of different platforms, and Zig's also open source and needs help supporting these platforms. So I'm not a spokesperson for Zig. I'm not a contributor or a core member of any foundation stuff or anything like that. I'm just a guy who likes to write Zig. But we have 3.1 thousand issues. This isn't like that's a big number, but it's not like, oh my god, there's so many issues, we shouldn't use Zig. This is very, very common with any language. In fact, let's pull up Dartlang. And if we look at Dart, I think we'll see the exact same thing. So we'll grab the Dart SDK. Yeah, 5,000 plus issues. I'm actually curious, does it give us a real number? 8,000 open issues. Like, this is totally normal. And I know that Dart and Zig are maybe not the most popular languages. So if we were to look at another one, maybe we look at TypeScript. I'm sure TypeScript has 5,000 plus issues as well. Yeah, 5,000 plus. Actually, just over 5,000. Good on them. So anyways, the point I'm getting at here, wrong tab. The point I'm getting at here is we have some issues and we'd love to see them solved. I'd love to see them solved because I would love to be able to teach people about fuzzing using Zig, the language that I want to write. But because I'm on a MacBook, I have some issues with that. So maybe a call to action here is come help contribute to Zig. I did start a contribution to fix an issue, and that people have been very receptive to that and very helpful. So it seems like a very welcoming open source project, which I feel like everyone hopefully knows that at this point. But okay, so anyways, despite us not actually getting to do some fuzzing, I do want to talk about in Zig 14. This is a brand new Zig 014. This is a brand new Zig 014 project. The Zig init output has changed. Let me make this a little bigger for you. I've had some feedback that my text is too small. Okay, so there's some comments at the top. It explains the conventions for main.zig and building a library and what you would do differently. This is the same from Zig 013 to my knowledge. I don't think anything has changed here. Maybe some of the comments, maybe not. It gives you a test, just like it has always, although I think this test has changed, perhaps. Yeah, not too sure. I don't remember what Zig 013's test that it gives you out of the box looks like, but this may have changed. And then also, there's another test for using another module, which I don't think Zig 013 had. So you get some extra tests. But the thing that I was really excited about that I wish Go did is when you generated a new Go project, I think they give you a test to work with, but they don't give you a fuzzing example. And Zig has a fuzzing example as a part of Zig init. So whenever you initialize a new project, you're going to get an example of fuzzing and how to fuzz things. So I think that's really neat, and I think that's worth talking through. So a fuzz test, if you haven't watched the Go video, I can't stress enough, you should check that out. It'll walk through what fuzzing is and all that. But the short and sweet is that fuzzing generates random values under a set of constraints, and that set of values get piped into the functions that you provide them to. So for example, if you have a function that takes in integers, i32s, for example, it will generate a bunch of random i32s and try things out. You can get into some really interesting examples. So like, let's say you have a function that takes in floats, f64s. So you're probably coding for most different floats, but are you coding for infinity? It might generate infinity. It might generate, all these different values that are technically valid, but things that people often don't think about. The example that my video is on in Go has you reversing a string by iterating through the slice of characters and swapping them not one at a time, but essentially swapping their places until you have completely reversed the string. What that means is you get into a really interesting example where, actually, I guess it is one at a time. Anyways, what you get is a really interesting example where that works fine with most strings, but if you throw an emoji in there, you now have an issue because an emoji is multiple bytes and it will be split in a way that doesn't make sense to split an emoji. It'll be reversed in a way that more than likely is not a valid value anymore. So you get into a weird example where, because of fuzzing and what fuzzing does, you end up finding a test that is a case that essentially is valid based off the type specification of your function, but one that you probably didn't account for. And that's the whole idea of fuzzing. So with Go, you can fix that by swapping from characters to runes, and there are other ways to approach things and do all of that too. But anyways, check out the Go video if you want to learn more on that. For Zig, I just want to talk through what you get out of the box with a Zig 014 init. So you get this test. It's a fuzz example. Fuzzing is a test just like any other test. We have a context here. So you can see that this context is a struct. It has a function. In our case, it's called test1. You can see that the context that it gets is this. And then it has input. And the input is a string. It's a slice of const u8. This can return any error or void. And then we don't need the context here. But what we can do is we can use standard testing expect to check to see that these are equal. Or sorry, they're not equal. And then we have a u8 for the type here. We have the string can you find me, and then b is our input. So this value right here gets generated. This input value gets generated by the fuzzer. So the fuzzer will do things. It will generate those different possible permutations for input and then pipe it in here. And when you fuzz things, it continues to execute multiple test cases against it until certain criteria have passed. So you can configure that here with options if you want to configure the way that fuzzing works. And then there's more information, of course, on the Zig documentation website as well. So anyways, someone had asked in the comments on a previous video what my favorite Zig 014 feature is. Unfortunately, I can't use my favorite Zig 014 feature on my MacBook. So it is fuzzing. I loved it in Go when it was introduced. I used it like crazy, and I was able to find all sorts of edge cases for libraries that I was building that should be fixed. And I guess one thing I'll add, like there's benefit to fuzzing user-facing applications for sure, especially from security concerns. But one thing that I'll add is that if you are building a project that is intended to be used in another project to build something, either in another project or a user-facing application or something like that, at some point you start to get so abstract from the actual people who are building a user-facing application with your code, especially if your library is used in another library, which is used in another library, which is used in a product or project, I should say. It becomes really valuable to fuzz because you essentially are trying to handle all these edge cases that, as your project gets included in more projects, increase the footprint of where your project could be used and the different types of values that could be passed to your project. So yeah, fuzzing. That's my favorite Zig 014 feature. I hope to be able to use it soon. I'm going to take a look at that issue and see if there's anything I can do to help out. But in the meantime, check out Zig's issues and see if there's any that you can take a crack at as well. Thanks, and have a great day.